Hello, hello, good morning, good morning, good morning, good morning. The saga continues of building the glowing AI commit button. Good morning, good morning. How we doing? How we doing? How we doing? Let's make sure that we're live on X and on YouTube, because we have Restream IO set up today. So we should be live on both platforms, which would be absolutely incredible. Alrighty. So our goal for today is to figure out the base for our switch. So we need to figure out the bottom part of our switch here, the base that's actually going to plug into, so I don't have to hold it in my hand when we're clicking it. And then once we have a base set up, we're going to have to start with a prototype wiring diagram to wire this to a microcontroller. And from there, when we have the microcontroller wired up, we will be able to write some code so that the switch can interface with our computer, and it can tell our computer to do stuff like send a commit from GitHub. And the plan is right now that we can have a some code, use an LLM like ChatGPT to have the commit automatically place a meaningful message based on what kind of code we are committing. I hope that makes sense. So like AI will go through and look at what code we're committing, and after we press the button, and it'll say, hey, based on that code you did, this commit is you updated the user login. So you won't even have to think about it. Alrighty. So let's get right to it. We have to take the dimensions of these bottom pins, and then we have to throw them on the base that we're creating. Let's see how we can get that working. I'm just going to check and make sure that the levels sound all right on the mic, and then I'm not peaking on X, because that would really suck if this whole time the mic was set up poorly. Oh, they sound great. Perfect. All right, cool. So how are we going to do this? It looks like, so the bottom pin is probably the most important. I'll zoom in on this. So this is what I'm talking about here with the pins. So our base is going to eventually be a PCB, but for this prototype, we're going to make it just a 3D print, and then we'll solder wires to the connectors, just so that we can get a feasible prototype working. But so since the PCB won't be holding it, we'll make like a pretend PCB out of 3D print, and we have to have the hole positions line up with these 3 pins. So the middle pin is obviously just plastic, and that's the biggest one, and that's kind of like the one that will actually position the switch. And then the other 2 are the electro connections that are made when the switch actually gets pressed in. Like that. Alrighty. So. Let's check it out. Let's see what we can do. I think that we start with the center pin, because that seems like it's going to be the easiest one to start with. We get out of modeling view. Okay. And I'm going to design the base right next to the top of the switch here. So the base is 70 millimeters by 70 millimeters, and I want, or the button is 70 millimeters by 70 millimeters, and I want the top to be, and I want the base that it goes into to be maybe like half a millimeter wider than that. And we're gonna have to have the same, it's not gonna work. We need to go from diagonal. All right. There's nothing that makes you feel more like you have no idea what you're doing than live streaming what you're doing. All right, so I'm going to leave that there, and we're going to go 17.5. And, oops, what the hell? Why? 17.5 millimeters by 70.5 millimeters. Okay. And then from there, hey Sandra, happy holidays. How you doing? What's going on today? Good morning if it's morning time there. If it's not, still good morning. All right. So, and then the height of the base should probably be like half as short. Actually, it's gonna have to be a little bit more than half as short, because we have to factor in the height of the switch. Thank you, my man. Best of luck to you too. I'm trying to cook. I'm trying to. So, meaning the height of the base has to cover the height of the switch, the bottom of the switch here, and then it has to come up like halfway up the side of the button, just like the side of like a keyboard case would. All right, let's see how tall our switch is. So our switch is 8 millimeters. Okay. Then I think that we also make this 8mm for now. And this one we're going to print the opposite way. And you know what? I'm thinking that it should actually be wider. It should be wider than 70.5mm, at least on the outside, because like I had in the photo. Let me see if I can grab the photo real quick. Yeah, like I had in the photo. It should be, I want to try to make it look like this photo here, so it should be a decent amount wider, actually, than 70.5. So let's go back here. Let's go here. And then we're going to move this. Out of the way a little bit. And then let's start off with 74. By 74. And then oh, why didn't that apply? 74. What? Whatever, I'm just gonna delete this. We'll go 74 by 74. Okay, that way there we have enough room for this border, if we want to call it, to stick out a bit. And then we need to come up 8 with it. I want to have almost the same border radius. So we'll do 3, because that's the border radius we have on the switch. 3. Oops. 3. 3, beautiful. And then we will cut out the room for the actual button itself. So let's add, we're going to add a construction plane to the top of this. Right there like that. And then we'll make the body disappear for 1 second. We'll go top view. And then add center. Oh, we're gonna have to go here. We'll do one of those. Click here. And then we gotta add a square. then this one we are going to make 71 and a half. Or no, we're going to make 70.5. I'm just going to leave that for now. 70.5. And then we'll go to this. I'm going to take this plane out. We're going to go 70. Oops. No, not that. Stop. 70.5. Okay, nice. We'll take this sketch out. Why is that sketch not disappearing? Whatever. We'll delete that. We'll delete that. No. Okay, cool. All right, so I think that that's way not thick enough compared to this button, because this little section right here is going to be the outside radius. Where's the buy button? I don't have the buy button yet. I know, I literally got a message for that yesterday that said, "Hey dude, if you're gonna start working on this and doing stuff, then you should probably set up a pre-order button now, so that, you know, like, well, it's hyped up a tiny bit, people can pre-order it." But I'm working on the button. I'm working on the button instead. Can somebody build me a landing page, please? I don't want to do it. I don't want to do it. Just throw something together for me. I'm honestly thinking about just grabbing something off of, or just adding a product to the desktop website. That way there I don't have to deal with it. As terrible as that sounds. And then I don't have to make a separate website, but I'm just going to do it. I'll make a like ultra simple landing page. And that way there it's good to go. All right, so I'm overthinking this prototype. I'm going to I gotta just do this. Damn it, I put that on the wrong plane. What we'll do is we'll just move this. Yeah, we'll move that up like 2 millimeters. Or actually, we'll move it up 8 millimeters. So I'm going to move this up 8 millimeters, and then it'll be at the top. And then when I bring this down, it's going to like chunk out the whole deal. And it's going to make the space for our button to go in. There's bottom. We'll leave the bottom at 2 millimeters, so it's kind of rigid. We'll bring this in 3 radius. Bring this in 3 radius. 3, 3. Okay, great. So now we kind of have our bottom for the button. I still think that the outside perimeter should probably be wider, but for a prototype, this is going to be a great start point. All right. Now we got to add our switch, which is not going to be easy. So we'll start off with the main hole for this prong right here, which it looks like, I don't know if that symbol is radius or diameter. .8. We're gonna find out. How wide is the center prong for the Cherry MX key switch? The center prong, the stem of a Cherry MX switch, which is the part of the keycap stem connects to, which is part of the stem, part that the keycap stem connects to, has a width of 1.3 millimeter. I need to sign it because that's not what we're talking about. It's talking about the width of just wrong. It's wrong. Okay. What is the diameter of the prong on the bottom of a Cherry MX switch that mounts it to the PCB? It's saying it's 1.5. It's not. I know that it's not. I'm just measuring it right now with a caliper, because it's definitely not 1.51. 2. I need to get a much better caliper. All right, it's like 3.8. This 3.8 is definitely the diameter. All right. So we'll go to sketch, circle, and And then we're going to go 3 point, we should go 4, because you generally want to make things like 0.2 millimeters bigger than they have to when they have to interface. Like when this prong goes in there, if it's the same size, 3.8, then it won't actually work, which would be not very good. And now we have to figure out these pins, which that is going to be a fucking pain in the ass. And I'm not exactly sure how we're going to do that. Alright, so this is looking at the side of the switch. This one right here. And it is saying oh, this hurts my brain. It's saying that it's 2.54 millimeters in from the end. What we really want is how far away it is from the center of our pinhole there, which I guess this is giving it to us right here, that it's 2.54. So one is 2.54, and then the other is 5.08. So let's start with that. We'll use that. So this one, oops. This one is 2.54. Okay, and then the next one is 5.08. 5.08. Okay, awesome. And so now how far to the side is it? Oh, I think this is what it's telling me right here. Jesus, the schematic is insane. Okay, so I think that it's also 2.54. So I think we could do... No, it can't be, can it? Well, I think we're just going to try it. .54. I knew that trying to figure out these pin positioning situation was going to be difficult. So from there we can make a rectangle not like that though. Diagonal rectangle like that. And this should be the exact point of one of our pins on the bottom of our key switch. I'm thinking. Is that to the middle? Yeah, that is to the middle. And the width of it is 0.81. So we should just make it 1 millimeter. I'm pretty sure I'm overthinking this whole thing. No, don't do that. What? 1 millimeter. We got one of them. Yes. Jesus Christ. Okay. See if we can clean this up a little bit. All right, now we need to get the second pin. We can do this. All right, so we know it's 5.8 over out that way. We have to figure out how far this way it is now. Let's look. I'm going to look at my caliper first so I get an idea, and then I'll get the exact from the schematic after. It's looking like it's 5, 6, it's like 7. Is there any measurement on here that's like 7? There's 5.08. And then because this full distance is 13.95. Oh, it's 3.8. Nice. I think I got it. So we'll go here. I think this is going to work. 3. Oh, wait, fuck, what did I just say? 3.8. Okay. And then we'll grab this circle. We're going to do 1 millimeter again, if we can. Nice. Jesus. Now I'm thinking that's not right. Damn it. We messed up something here. So it's 5.08 out. All right, I got it. Needs to be 5.08 out. Why? And then 3.8 over. Yep, 3.8 over. Good. All right, and then 1 millimeter for the, god damn it. Okay. That sort of looks better, I think. But I also don't know. So I think we're going to print a test print of this and see how close we got with these pinholes is what we're going to do. And then that'll let us know right away if we got close or not. And then we'll erase all this stuff. And then we'll just send that to the 3D printer for now. Switch, pin out, test. We'll delete that. All right, slice it. And that's going to take 7 minutes. Wonder if maybe we should have a raft there. Nah, I think it's going to be fine. We'll try it. All right, so we are sending that to the printer right now. All right, so in recap, what we made is the part that actually, that this switch, the pinholes that the bottom of this switch will plug into. And we need to know that size because eventually we'll make a PCB that the pinholes on this will plug into, and then we won't need wiring or anything like that. So we'll just have we'll have the switch, we'll have a couple of RGB LEDs to make the translucent button glow. We'll have some capacitors and resistors, and we'll have a microprocessor to handle the communication to the computer. Alrighty. Cool. So this will start printing. It's just warming up the heating bed right now. And then basically if that ends up being the size that we like, we will add it to this, which is going to end up being the actual base for the button. And then we'll have a base for the button, and we'll be able to actually test the button on a surface, which will be nice. And then from there, we'll have to figure out where the microprocessor is going to go. And the microprocessor, so it's probably going to have to be thicker than what I have here, to be honest. This is probably not thick enough. And then also, it's probably just going to have to be thicker because I don't think that these holes are going to be tall enough to accommodate the height of the pins itself. All right, so we have a lot to think about here. I'm going to I'm going to grab a microprocessor. And then we'll start thinking about code and how we're going to get the code for this thing to work, which ChatGPT is going to help us out a lot with that. Let's see. I'm not sure if we're even. Oh yeah, we are. All right, so let's start talking to ChatGPT here. Connect a mechanical keyboard switch to an ESP32. I want it to plug into my computer via built-in USB-C on the ESP32, and I would like it to run a script when the button is pressed. We're going to start with just running a script. And then I'm thinking that we can possibly make a plugin for VS Code. And I think that Cursor uses the same plugins as VS Code. And then we can use the plugin to automate the git commit, git push for us. Because if we just have it run a script, then it's going to have issues with not knowing which directory to run the git add git commit -m and git push. If that makes sense. Alrighty. Let's see what it says here. So we need to pull up or pull down resistor. One leg of the GPI, one leg to the GPIO pin, whatever we want, on the ESP32, and then the other leg to ground. Use a pull-up resistor connected between GPIO and 3.3 volts if the switch is configured as active low. Configure the ESP32 as a HID device. Can act as a human interface device. This is what I need to know. This allows it to emulate a keyboard or similar device over USB. Use the Arduino framework or ESP IDF with the USB HID. Wow, that print already finished. That was so fast. All right, let's grab the print and then we'll come right back to this. Let's see. All right, the big reveal. Do we think that this is going to work? Oh no, it's not going to work at all. So, so the problem is the holes that we made for the connector, the pins. You can barely see them because they're way too small. 1 millimeter is way too small for that. Yeah, so what we need to do is we need to make those pins like at least 1.5 millimeters, maybe more. Let me see if I can just see if that looks like it's gonna line up. It might. I think that it does actually line up, which would be a miracle. Alright, let's make these pins bigger and then set another print. This is very exciting. We're going to delete that. Just going to make him 2. And then we can go smaller. What did I print this last one? That was 2 millimeter, 1 millimeter, 2. Yes. Okay. Oh shit, my bad. All right. All I did was make the holes bigger on this. These 2 holes. We're going to export it again. And then import it back into Bamboo. Except for not really. Okay. Open that up. Nice. Slice it. And then print it. I hope that's enough material in between those two that it doesn't become one circle. It is. Right. Nice. No. All right, we're printing. Nice, nice, nice. All right, so back to the code here. The diameter of the prong or pin on the bottom of a chair. No, this is not what we need. Human interface device dot begin. Initialize HID. Void loop. If digital read switch pin is equal to low, keyboard dot press key F13. Delay 100. Keyboard release all. This is nice. This, I don't want to say anything, but it seems like this could be straightforward-ish. We're basically just making a small keyboard, like a little tiny keyboard. Let's see what we can do. This is going to be the microcontroller we're going to use because it's tiny. And it will fit good inside of this. See how small that is? And then there's that. See, so this will fit inside of this somewhere. We'll hide that. And then the USB can just kind of like the USB-C. We'll make a hole for it, and it'll go out the side of it somewhere. We shall see. Let's just make sure we do have pin 4. Okay, great. And then we need to, we gotta grab our breadboard. I'm gonna grab another switch. Hold on, I'll be right back. All right. So here is our breadboard. I'm not actually sure if you can plug a mechanical keyboard switch into a breadboard or not. It'd be nice if you could, but I don't think it's gonna, I don't think the pins are gonna be long enough. Yeah, it doesn't look like the pins are gonna be long enough, which is super annoying. So I think that instead of using the keyboard switch, we're going to have to use a different switch. All right, I'll get a different switch. So we are looking for small button. Like one of these. Just for now, so we can write the software with. Whoopsies. Right. So that is a tiny button right there. Right? Small button. That we're going to use for now just to prototype with. So, we'll throw that in there. We can do one of these. So it's in there like that. I don't know if that's going to work. That might work. All right, so that finished printing from the printer. This is supposed to hold our mechanical switch. So now we can test to see if this actually fits. We just made. Let's see if this fits on this. It's looking like the center pin is a little bit off. Damn it, we're so close too. I wish I had a better way of showing this to you, but for whatever reason that center pin does not line up. Just a tiny bit off. So how are we going to go about fixing that? The placement of the pins is perfect, but that center pin is not correct. need to move that center pin over. I think that if we just move the center pin over, we might be doing good. Honestly, like a millimeter. Weird. Very weird. So then, all right, so we'll move. This to the right. One millimeter for now. I'm going to delete that. Luckily, these print really fast. Okay, and then we'll export STL. Switch pinout test version 3. Save. We'll pull open Bamboo Studio again. Delete this. Add version 3. Oh my god. We don't want to print the switch again. Export to STL. Version 3 again. Replace. And there we are. Boom. And we'll print it. We might be closer. We might be closer. All right. So while we got that printing, we'll go back to the button situation. So what I should probably do is add solder these pins on there, unfortunately. Like this. That way for prototyping and all that, it'll be much easier because then these pins right in there like that. So I think that's what we're gonna have to do real quick. What time is it? It's 6:40. We have 20 minutes. That's gonna be just enough time to throw these pins onto onto it over there. Let's do it. Alright, so we're gonna have no mic for this part because I don't have a mic over at my soldering station. Which is kind of annoying. Can you do the mic from the... No, I don't think you can. That would be cool if you could do the mic from the iPhone. Oh, I think you can. Oh no, I might have just crashed everything. Alright, we're not going to do that right now. Alright, we're just going to have no mic for a minute while we do the soldering of this, and then I'll come back, and then we'll have a mic after that. Alright, so that print finished. And we gotta see if it fits this time. I'd be surprised if it did. Oh my god, so... Oh, it fits. Yeah, it fits perfect. Why won't it focus on that? Focus on this. Okay, I just want to focus on it, but I'm telling you right now, it fits perfectly. Could probably make the positioning hole a tiny bit smaller, but it's not really needed. Okay, nice. Snug like a bug. Cool. So, from there we can make this a little bit taller, maybe 1 millimeter taller. And then we can print the actual we can make it 1 millimeter taller, and then we can print the actual base. Where is it? Body. There we go. Nice. Because how tall is this? Is this 2? It needs to be at least 3. And then we'll go to the bottom of this. Go 3, 3, 3. Okay, cool. And then that should be perfect. It's not going to be perfect. Now that I said that, it's definitely not. But we'll see. So go base test V1. I'm thinking this needs to be a millimeter taller. I'm going to go for it. That way there it actually covers some of the side of the top of the button. bamboo. Bring up the printer. Prepare. Get rid of that. We'll add base B1. Slice this. It's going to be 30 minutes. We'll send it. Cool. Alright, while that's printing, we'll go back to our software and hardware setup. So this button does not want to stay in there good at all. It's really annoying. Alright, that seems better. I gotta grab some wires. I'll be right back. So, methinks there's 4 prongs on this button here. I think that I have to use the bottom and the top, but we're going to find out. And then I'm going to use pin 4 and ground on this. But I need to figure out, oh no. I covered up the pin. I covered up the labels for the pins on this, so let's see. Pin 4 is 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4 from the back. 4 from the back. Okay. Two, 3, 4. All right. And then we gotta go to ground with the other side of the button. So that is our prototype board there. We have the button. Clicky clicky. And then we have our board. Could be promising. So we need to write some software to this and check to see if we are set up right. So let's go into we're going to pull up VS Code. Which I don't know why it's not in my tray. All right, I'm opening up Desktop Alpha so I can grab the specs for how to set up this board. And basically we are in Platform IO right now, which is going to be how we communicate with our board. And then we have to find the ESP32 dev kit. Right here. Finish. Okay. And then we can pull open main. I'm just going to see if we can get this set up quick, and then I'm going to turn the stream off because I got to let my dogs out. Oops. We're going to see if key F would work. Keyboard. press F. Okay. HID project is what we need to install. So we need to install this onto the situation here. Go to libraries. This is one of those search boxes that it needs to be like exact. All right, and then we'll add it to commit button. This is going way too smoothly. So I don't expect this to to work. I think I'm gonna unplug my keyboard so I can just plug that into my microcontroller. I just plugged my microcontroller in and unplugged my keyboard. That's it right there. Maybe. HIDH, no such file directory. Looking for HIDH dependency. Check out our registry. Let's see. Sometimes, like, ChatGPT is not great at this, so sometimes it just does not understand. Yeah, this should be installed. to install HID. My keyboard's unplugged. Hold on. Gonna see. Huh. Let me get rid of this. Of course. I don't know why he doesn't like this. It's like trying to give me, ChatGPT is trying to give me like a framework that doesn't actually exist. All right, we're gonna try this. If it doesn't work, then I'm getting off, and we'll figure it out tomorrow. Hey, babe, I'm getting off right now.